So welcome to 5.3. In 5.3, we're going to introduce a totally new concept called slope. So I want you to look at these jump ramps and try to describe which one would make the motorcycle jump higher. Well, let's look at this first one, right? If you're jumping off that, you might go like that. And in this 1B, you might go like that. So I think it's pretty clear that 1A would make a motorcycle jump higher. We're asking for higher, not farther, higher than in B. Now, in number one, both of the ramps had the same length at the bottom, but they had different heights. And the one with the higher height made it jump higher. Now let's look at the harder version. Both of these in number two have the same height, but they have different lengths. So which one do you think would make you jump higher? Now this one, I think you would go sort of like that. This one, assuming you can get up the ramp, would do that, I think. And so I think B, assuming you can get enough speed up there, would make you jump higher. Now, this is not a lesson about motorcycle jumping. But what the point of this is that both of these numbers, how high the ramp is and how long the ramp is, are important to answer this question. And we're going to make some mathematical concepts based around that. So we're going to be learning about slope, and you're going to be drawing some ramps. Now, what shape are these ramps? Well, these ramps are right triangles, right? A right triangle goes, at least the way we're going to draw them, is straight up and down. This side is straight up, and then the bottom of the triangle is perfectly flat, and this is a 90-degree angle here. And you're going to be drawing these ramps under lines. So let's see that. So the slope of the ramp is this. Now it's not just how long it is, it has a direction. See, there's an arrow there. How much it goes up, called the rise. You rise up in the morning, over, we're going to make a ratio, over the run. And the run is always to the right. Notice that arrow there. So the run is always to the right, the rise is always up. And so the slope of a ramp is its rise over its run. So what would be the slope of this very first ramp? Well, it would be 2/7, because the rise, how much it goes up, is 2, and the run along the bottom is 7, and you just make it a fraction, 2/7. So what would be the slope here? Well, the rise now, it goes up 8, and the run is 5, and you leave it 8/5. You do not want to make this 1 3/5. Because you want to be able to see this rise, right? We're comparing the rise to the run. Now you can see that this one points more up, right? Assuming the motorcycle could jump up, get up the ramp, that would make it jump higher. And 8/5 is bigger than 2/7. The bigger the slope, the more the motorcycle will jump, assuming he can get up it. And this one really is actually too big. It's not really a good jump ramp, right? It would be hard to sort of negotiate that. But the bigger the slope, the more the angle here points up. So what's this one? Well, the rise is 2, the run is 1. And we're going to still simplify our fractions, and we're going to say the slope here is 2. Now we always simplify our fractions, so we always simplify our slope. So what is the slope here? Well, the rise is 2. How much it goes up is 2. The run is 6. And so you're not going to say it's 2/6. You're going to say it's 1/3. The slope here is 1/3. Now, inside that ramp, I'm going to draw another ramp. Now this ramp has a rise of 1 and a run of 3. But what's the key thing? Both of those, the angle at the top, the very top of the ramps perfectly line up. And the reason they perfectly line up is because they have those two ramps, one is bigger than the other, but the angle of the ramp, the top of the ramp, lines up because they have the same slope. if you have, say it's feet, 1 foot by 3 foot ramp, and a 2 foot by 6 foot ramp, the 2 foot by 6 foot is bigger, but the angle of this at the top will always line up. They have the same slope, and that slope is 1/3. So let's look at this one. Well, this is 4/12. That also simplifies to 1/3. Does that mean this 4/12 one will line up with the other two? Yes, it will, right? So there's the one we just made. That was 2/6. And then there's the original one that's 1/3. And you can see, I'm not going to write that, but they all line up. They have the same slope, 1/3. So let's see that again. This one is 9/6, but you wouldn't leave it that way. You would simplify your fraction. And this has a slope of 3/2. Does that mean it would line up with a ramp that was 3/2? Sure it does. Let's try another one, 18/12. Does that also simplify to 3/2? Yes. Does that mean it would line up with the other one, the 9/6? And the 3/2, yes, they all line up because they all have the same slope. All right, so now we're going to use that concept to find the slope of those rays that you were graphing in the last lesson. So let's see this. So we're going to draw some triangles. Now, I'm going to get you started, and then I'll tell you how to start on a later screen. So what I'm going to do, I'm going to make a point at 0, 0. Now remember, our proportional relationships will all start at 0, 0. And then I'm going to put a point right there at 3, 2. And I'm going to put another point there at 6, 4. All right, and another point here at 9, 6. Okay. Now we're going to draw a ramp underneath this. Okay, so we're going to go take one of the points, go straight down, and then straight over to the other point. And you can actually do this anywhere. You take any point, go straight down, and go straight over. Remember, we're making a right triangle. Right? I get people who want to do this. That's a triangle, but it's not a right triangle. Right? You want to go straight down till you're even with the previous point, and I will teach you how to make those points in a second, or how I chose them. And there's your ramp. All right, so now here we have these ramps. Find the rise, find the run. Well, the rise, I would recommend do not look over at these numbers. Count how many boxes they are at this point. We'll look over those numbers in a second, but the rise here is 2, right? It's 2 boxes. Each box here is worth 1, and the run is 3. Same thing here, right? The rise, you don't want to look here. You could subtract 6 minus 4, but it's 2 boxes high, right? And the run is 3. So what is the slope of that ray? You would say the slope is 2/3. The slope of the ramp is 2/3. The slope of the ray lining on the top of it is also 2/3. So let's do another one. So in this one, there's 0, 0. I'll do this one in red. So there's 0, 0. Then there's a point there at 1, 4. And there's another point at 2, 8. I'm going to do the same thing again. You start at a point, you go straight down until you're even with another point. You can go straight down till you're even with another point. So find the rise and find the run. Well, the rise is 1, 2, 3, 4 boxes up, and the run is 1. Right? You could do it here. 1, 2, 3, 4. Rise is 1. The slope of this one is 4/1, but we simplify that to a slope of 4. So you find the slope of the ramp. You find the slope of the ray that lies on top of that ramp. And that's telling you how much toward the top, straight up, the ray is pointing, right? 4 is a bigger number than 2/3. Hence, the ray in the slope of 4 is more pointing straight up. So how did I pick the locations you saw on the last screen? What I was doing was I was going along, and I was not picking locations where the ray missed an intersection. What's an intersection, right? Where 2 roads cross. Where 2 roads cross, that is called the intersection. So you're looking where the ray hits an intersection. That's how you pick your points. And you can go back and look at that last two graphs and see that's where I picked my intersections. All right, so let's try this. So we're going to first pick our intersection. 0, 0 is an intersection. Then I'm going to go along. That's a miss. That's another miss. That's a miss. Very close. That's a hit. Now another miss. Clearly a miss. Another miss. And there are the good intersections. Now, you only need 2, but you want to get more than 2. And the reason you want to get more than 2 is the good intersections will always be evenly spaced along the ray. Notice, right? They're exact. So, for instance, if you thought this one maybe was good, even though it's not, right? These two are not the same distance from each other as the first two. They're not evenly spaced. So something has to be wrong, all right? It has to be there. So then you pick any of those, you go straight down, so you get even with the previous one, and then you write. You can go straight down from any one of them, and then over to the previous one, and make your right triangle. The rise here is 3. The run is 1, 2, 3, 4. And so the slope of this ramp and ray, are 3/4. Let's try another one. So pick your good intersections. 0, 0 is good. We're going along. No, no, no. Oh, there's one. No, no, no. And there's one. Okay. So now we're going to make our ramp. Right, you go straight down till you're even with the previous good intersection. Straight down and even with the previous good intersection. So I'm going to do it up here just so I don't overlap. 1, 2, 3, 4, 5. So the rise is 5 boxes. The run here is 2 boxes. And the slope of this one is 5 halves, right? We're not going to make that a mixed number. You're going to leave it as 5 halves. And 5 halves is a bigger number than 3/4. Hence that ray points up. Now, if you miss an intersection, will you still get the, say you didn't see that, and you did this humongous triangle. Well, that one has a rise of 10 and a run of 4. Guess what? That's where you're going to have to simplify. So if you miss an intersection, and it happens, you'll have to simplify a fraction, right? 10/4 simplifies to 5 halves. But you want to try to pick 2 good intersections that right in a row so you don't have to simplify and get right to the answer. The slope is 5 halves. If you get a fraction that needs simplifying, it means you missed an intersection along the ray. So now, they don't all start at 0, 0. If they're proportional, they start at 0, 0, but they're not all the ones we're going to do are proportional. So this one is not proportional. So that's why you got to be careful about reading these numbers. All right, you can't. So let's find the good intersections. There's one there. There's one there. There's one there. Notice I did 4 of them. They're evenly spaced, so I'm pretty good. All right, so now you don't go down here to the bottom, right, like you did, because we didn't have 0, 0. You come down to you're even with the previous intersection. Down and then previous intersection is what you need. The rise is 1 box, the run is 3. The slope of this everywhere is 1/3. This one, same idea. So that's 0, 4. The next good intersection, no, no. Yes, right there, right there. Those are evenly spaced. Down until you're even with the previous intersection. The rise is 3, the run is 2. The slope of this one is 3 halves. Horizontal rays have a slope of 0. Okay, so these are horizontal, right? The table you're writing on hopefully is horizontal. Not all the desks in my class are horizontal, but some of them are. The floor hopefully is horizontal. It's flat. So now, what is the rise of this? Right? There's the number 9 there, but the rise is not 9. The rise is how much it goes up. How much does that go up? Well, it starts at 9, still 9, still 9, still 9, still 9. The rise of this is 0. Doesn't matter what you make the run. You can make it any of them. You can make it 1, you could make it whatever. What is 0 over every number as long as it's not 0? It's 0. The slope of that is 0. The rise of this one, also 0. I could make it over 1 box, or I can make it over 6 boxes, doesn't matter. The slope of all horizontal rays is 0. 0, right? When 0 is on the bottom, that's no good. But 0 on the top, in the numerator, you always get 0. All right, so let's practice. So that's not perfectly drawn, but I mean 0, 8 to be a good intersection. You go along. The next one seems to be right about there and right about there. And again, I didn't draw that perfectly, but you've got to get an evenly spaced pattern with whatever you pick. So that helps you figure out what's really going on. So you go straight down and then straight over to the previous intersection. The rise here is 1. It goes up 1 and over. The run is 5, and so the slope is 1/5. This one has 0, 0. There's another one. There's another one. Go down, over. Looks like I have the exact same answer. They both have a slope of 1/5. So can you look at those two rays and tell me some relationship between those two rays? Well, hopefully they look parallel to you. Parallel meaning they will never cross each other. They will never intersect, right? They're going side by side forever. And that is always true. If lines or rays have the same slope, they're going to be parallel. Even backwards. If they are parallel, they always will have the same slope. Let's try this one. So this one, you have 0, 0, and then it looks like we have right there and right there. I'm going to do this one up here. And so 1, 2, 3, 4, 5 is the rise. The run is 1. This is a slope of 5, right? 5 over 1, which is 5. Very different. Look how different that is than the 1/5, right? 5 is a big number. That ray points up toward the sky. Slope is 1/5 is a relatively small number, and it's a pretty flat slope, a low ramp. So this looks like a special case. Let's look at that. We have 0, 0, and then it seems to hit everywhere, right? It seems to hit everywhere. So you go down and even, so the rise is 1, the run is 1. What's the slope? The slope is 1. Don't leave it 1 over 1, it's 1. And this is where you can see the simplifying, right? If you say you missed 1 and did that, you would get 2 over 2, but you still get 1. That is the slope. When you go right down the middle like that, you get a slope of 1. So what kind of line is that? That is horizontal. All horizontal lines have the same slope. The rise here is 0, right? It doesn't matter what number is there. It starts at 5 and stays at 5 forever. So the rise is 0. You can make the run whatever number you want as long as it's not 0. The slope, all horizontal rays have a slope of 0. Good luck on the homework.